In this lab, management wants us to use the OSPF routing protocol to share routes between the routers in the network. Specifically, management wants these three routers to share routes with one another. That way, the routers can find the quickest and shortest route for IP packets to get to their destination. OSPF stands for Open Shortest Path First. It is a routing protocol used inside large networks. OSPF routers talk to each other to map the network and choose the best routes. Why is OSPF used? OSPF finds the shortest path to send data based on metrics like speed. This makes routing fast and efficient. You can tell the difference here with the green areas showing the path that OSPF would choose because it's the shortest path and the shortest amount of hops to the destination. The red path would be an alternate path that OSPF would not choose because it has more hops to get to the destination. OSPF adjusts quickly when the network changes. So for example, if this router went down, then OSPF would change how it would get to its destination based on the advertising routes that would be advertised to the routers so that they know what the fastest path to get to the destination was. Let's start the OSPF configurations with router 1. Let's console into router 1 with PC1. Let's do a show IP route command to see what routes R1 is currently connected to. So we're only interested in directly attached subnets, so let's be a bit more specific and use the show IP route connected command. Here we can see the three routers we can advertise using OSPF. Now, remember in a previous module we had found a very specific set of steps to configure OSPF. So let's first designate area 0. In this case, management has told us that all these routers are in area 0. Having only one area limits the segmentation and scalability, but since this is a small basic network, that's A-OK. The next step is to decide which interface networks we want to include, which we can see in our show IP route connected command. Then we need a router OSPF process ID and a router ID. For those, we'll use 1, and for the router ID, 1.1.1.1. Next, we need to write the networks with their wildcard mask along with the area they are in. As we discussed before, all the routes will be area 0, hence the A0 after the wildcard. Remember to save your configuration. Then let's move the console cable to router 2 so we can set up its OSPF configuration. Remember the steps for OSPF. We know everything is area 0. So step 2 is to find a network on the interfaces that we want to include. So let's do a show IP route connected command. Then let's configure the OSPF with the process ID, which should be the same process ID across all the routers in this OSPF domain. So the process ID here is OSPF1. Next, the router ID, which for this router, since it's router 2, will be 2.2.2.2. Finally, the two directly connected networks on the router interface we want to advertise, followed by the wildcard mask and the area 0. Notice a log tells us that we already started sharing routes with router 1. It might take a little bit for this log to appear, but if you sit at that terminal, you'll see it pop up. Save and update your notes. Then move your console cable to the last router, router 3. In router 3, we just have to follow the same steps. So first, we'll see the networks currently connected to router 3's interfaces with the show IP route connected command. And we're skipping step 1 because we know that everything is area 0. So router OSPF1 is the next command, putting the process ID. Then the router ID 3.3.3.3, since this is router 3. Then the two networks from the show IP route connected command, followed by the wildcard mask and area 0. Notice again here that an alert log will appear stating that the OSPF started sharing routes with router 1. Save your configuration, save your packet tracer file, and update your notes. Now, Let's verify the OSPF we configured by doing a show IP OSPF neighbor command. Here we can see the neighboring OSPF routers, which is router 1 in this case. You can tell by router 1's OSPF router ID 1.1.1.1. With the show IP OSPF interface command, we can see more details such as the designated router, which handles the routing and traffic flow for the broadcast network segment, and a backup designated router, which would become the new designated router if the designated router went down. With the show IP OSPF database command, we can see all router IDs advertising routes to this router. And finally, with the show IP route command, we can see the learned OSPF routes. We can tell which routes were learned by OSPF by looking at the routes with an O next to them. We can also see where these routes were learned from by looking at the via 192.168.40.6, for example, which is an interface on router 1. That means the routes 192.168.10.0/24, 192.168.30.0/24, and 192.168.40.0/30 on router 3 were all learned from router 1. Awesome! You completed your second OSPF lab now. Save your packet tracer file and update your notes. Then write up your narrative. After that, share the Google Drive folder you have for this lab with anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.